In our last example here for for lesson 2.3, we're going to find some zeros of a polynomial function. Now this says find your real zeros. So I'm going to talk about real zeros versus rational zeros versus imaginary zeros. It's quite a difference. So whenever you have rational zeros, that means you'd have like integers, fractions, decimals. So you could have any of those for rational zeros. For a real zero, this could be either you could have for real zeros, this includes all of the other rational zeros and radicals. So if you have like square roots, you could also have cube roots. But whenever they're real, then that just means that they are not basically integers, fractions, or decimals. Now imaginary zeros, that just means where you'd have something like a square root of -3, which would just be an I radical 3. So you can't have imaginary zeros if you have a real zero. Alright, so let's look at example 8. So the first thing you need to do is you need to do the P over Q. So if you do your P over Q, that means we need to find factors of 6 over factors of 3. So what we have here is factors of 6. Well, that would be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. All of your factors of 3. So that means that we're going to end up with the factors of, well, what you do is you compare everything on top with everything on the bottom. So this 1 is going to be paired up over 1. You have 1 over 1, you have 1 over 3. So that means you'd have a plus or minus 1, and you could also have a plus or minus 1/3. Then after that, you have to pair up your 2 over 1 and 2 over 3. So that means you're going to have a plus or minus 2 and a 2/3. Next, you're going to pair up the 3. So when you pair up the 3, 3 over 1 is 3. 3 over 3 is 1. Well, you already have 1, so it wouldn't make any sense to write 1 down again. So you're going to have a 3. And then once you do the 6, well, 6 over 1 is just 6. That's going to be a 0. And then if you take 6 over 3, that's a 2, which in this case we already have also. So now these are your possible factors of, or possible real zeros. And since we have a degree of 5, what you need to do is you're going to have to do synthetic division at least until you get down to an x squared. Once you get down to an x squared, you can either factor or use your quadratic formula to find your other two zeros. So let's go ahead and start with 1. So if we do synthetic division, plug a 1 in the box, bring down the 3, -4, -10, 10, 7, and -6. So you bring down the 3. 3 times 1 gives you a 3. -4 plus 3 is -1. 1 times -1 is -1, so you get -11. 1 times -11 is -11. So you get a -1. And 1 times -1 is -1, so you get 6. When you add those, you get a 6 here, which means you have a 0. So that means that we have found one of our zeros here. So 1 is one of our zeros. Alright, so now what we're going to do is we're going to use your depressed polynomial. And if you use your depressed polynomial, then what you're going to do is you're going to use the 3, -1, -11, -1, and 6, and you're going to do synthetic division again. So you could try 1 again. We're going to do it with -1. So you say -1, and then we're going to go 3, -1, -11, -1, and 6. And since your first number and your last number is still 6 and a 3, then you still use the same possible zeros up here. So I'm going to choose -1 in this case. So when I choose the -1, I did a little work ahead of schedule here, and I plugged in 2. And if you notice, when you plug in 2, you also get a remainder of 0. So that means that 2 is another 0. So left over, we get a 3x squared plus 2x minus 3. What we're going to do is set that equal to 0 because there aren't any factors of -9 that add up to 2. Alright, so once we have this polynomial written out, we can, if you can't factor, then you got to use the quadratic formula. So the quadratic formula says x equals a -b, which would be a -2 plus or minus a 2 squared minus 4 times 3 times a -3 all over 2 times 3. So now we just have to simplify this. You get -2 plus or minus 4 plus 4 times 3 is 12 times a -3 is 36 all over 6. So we have x equals to -2 plus or minus radical 40 over 6, and you must reduce the radical 40. So that becomes -2 plus or minus square root of 4 times square root of 10, which is just a 2 radical 10 over 6, which if you reduce, you have to remember the rule of 3. So the rule of 3 says that this -2, 2, and 6 all have to be divisible by a common factor, which in this case they are. They can all be divided by 2, gives us a -1 plus or minus radical 10 all over 3. So here are the rest of your zeros. Your last two zeros, well, your first two zeros, first 3, we had zeros at -1, 1, 2, and then we also have one at -1 plus or minus radical 10 over 3. So that will be the longest problem you have and the most tedious. But you find out that you get 3 rational zeros. Okay, 3 rational zeros, and then you have 1 real 0. It's not imaginary because it's not doesn't have an I, but there's 2 real zeros right there.